Of string name, we need to return the list of repeating names and the indexes in the array. For example, let's say that we're given an array that looks like this. We want to return a list, so this is going to be our new list, and it's going to be of names that have been repeated in our list and their specific indexes. So I'm going to be using this as an example, and we're going to get the same exact output. The way I'm going to be doing this is with hash maps and array lists. So this is a pretty inefficient way to do it. I'm sure there's a more inefficient way using our actual mapping classes, but I'm not 100% familiar with everything, still working my way through it. So we're going to solve this problem that is a O to the n squared, and it's not the best runtime, but it'll still get this done. So we have an import statements. We're importing our array list and hash maps. Those are the two collection classes that we're going to be using. So we have our public class, public static void main, and inside of here we have our default array of string name that we're given. We're just hard coding this to pass it in here. Now we are going to create a map to store our variables. This is a hash map, and it takes string as a key and string as the value that we have here. So we have key and value. The key here is going to be the name, and the value is going to be the array list of indexes. This array list we are going to convert to string and then put it in our hash map. So that's how we are going to do it. Now for hash maps, if we have a key, the key needs to be unique, can't have the same key. So there could possibly be a way to compare these, see if it's already in here, do like an if statement, and then just add something to an index and then push this in here. That could be another way to solve this. But the way I solved it here is I then made our array list, type integer to store our indexes, and then we have our string equal, and we'll see what this does in a second. I probably coded this in after I wrote this for loop. So we have two for loops because we want to compare everything in an array. This is the easiest way to do it. We send our int a equal to 0. We run this as long as arr.length because we want to run through the entire array. And then we're going to do b is equal to a plus 1 because we want to check everything except for the current one that our a is. And then we're going to run this as long as arr is less than our array length, and that's for b. So we run this inside of here, and then we're going to compare our current element at the array index. So like array 0, we're going to compare this to everything inside of here. Next iteration, on the outside for loop, we take Bill and we compare it to everything inside of here. And so with Alicia, everything inside of here, and so on and so forth. If they equal to each other, we are going to add our index A and our index B to our array. So that's going to store our indexes. Just like that, it's going to store them. And then we are going to set equals to be our array element that we are currently looking at, because if they're equal, that means we have this reoccurring more than once. Now, if our equal does not equal what we've set it to be default, which is just nothing right here, we just basically declared it. If it does not equal the default, that means we've hopped into this if statement, we've changed our equal, and we can do hash.put, and then we are putting the name as well as the array list, but the toString of it, inside of our hash map. And then after we do this, no matter what, we are going to do int arr.clear, and then we're going to set our equals to this right here. Now, it could possibly lead to slightly better, but not significantly better runtime if we just put it inside of here. That way it only resets if we were ever in this if statement. And then we're just going to print our list here. So we can run this and see how the code works. Pulling up this, we can see that we have test at the 0 and 5th index, and then we have Alicia at the 2nd and 4th index. And that's how we will look at and run through this coding exercise.